Okay, guys, so let's get started without any further ado. In today's class, we're going to talk about the assignment of IPs. So, how do you practically assign an IP address to your system? So, we learned about the categories of IPs in the earlier sessions. We learned what classes are, what the relevance of each class is, and where do you use each class IP. Today, we're going to talk about some practical topics. How do you assign an IP address? Okay. So, when you talk about assigning an IP address, guys, there are two important ways. One, you can assign it manually, or two, you can assign it automatically. So if you go to your command prompt right now, okay, and if you type IP config, this IP that you get here is a private IP as discussed earlier. And this can be assigned in two ways as mentioned. Okay. One, you can get it automatically from a DHCP server, or you can get it manually as well. Okay. But we'll go with the manual method first, and then I'm going to talk about the DHCP method. Okay. To assign a manual IP, guys, you need to know these three pieces of information. What IP you want to assign, what is the subnet mask for it, what is the default gateway. Now we know already what an IP is, okay, but we never talked about subnet mask. So let's discuss this. Okay. So your subnet mask is basically for the computer to understand which class an IP belongs to. Okay, so we can understand which IP belongs to which class with the network and host portions. Class A has one network portion, class B has two network portions, and class C has three network portions. We learned about this in the last session. Okay. But how does a computer get to know which which IP belongs to which class? So what a computer does instead is rather than using N and H as the alphabets and to distinguish, it uses the binary numbers, ones and zeros. Okay. So for the network portions, it assigns the value one. And for the host portions, it assigns the value zero. So now when you talk about class A, where it has one network portion and three host portions, so in the first portion, it has all ones. And in the last three portions, it has all zeros. And now when you convert that from binary to decimal, you get the number 255,000. That's the subnet mask for class A. For class B, similarly, when you have two network portions and two host portions, subnet mask would be 255,255,000. So first two portions have all ones, last two portions have all zeros. Okay. And finally, when you talk about class C, there are three network portions and one host portion. So the subnet mask is 255,255,255,0. Okay. So all the network portions will be converted to 255s. Host portion will stay at zero itself. Okay. So this is the subnet mask. So when a subnet mask as such is assigned, the computer now knows, okay, this is a class C IP. And in class C, it understands the range. So it can connect a maximum of 255 devices, not more than that. So the subnet mask allows the computer to understand what is the class and what is the range of IPs it can communicate with. Okay. Then you have default gateway. Now this is basically a fancy name given to your Wi-Fi router. It acts as a gateway between your private network and the public network. So if you remember this diagram, which we covered earlier, this one over here. If you remember, your router is a device which provides the internet wirelessly to all your other devices in the net, your Wi-Fi router. And this Wi-Fi router gets a cable from outside your house, from the ISP, Internet Service Provider. So this router is here acting as a gateway for all the private IPs devices to communicate with the internet. So when any of these devices wants to send a packet to the internet, it always goes to the gateway here, the router, okay, the default device to which the packet is sent. And from here, it reaches the internet, hence the name default gateway, to either packets entering inside the private network or going outside of the private network. This is the gateway they have to pass through, hence the name default gateway. Okay, so these are the three pieces of information that you require to assign a manual IP. Now the question is, where do you assign it? Okay, so as mentioned, to assign it manually, the first method, you can assign it from the control panel. Okay, and to assign it manually, this is the procedure for it. Okay, so you go to control panel, open network and internet, go to network and sharing center. Then you click on change adapter settings. Then you right click on the adapter, go to the properties, go to IPv4 properties and assign the following IP. Okay, quite lengthy, but let me show you practically now. So search for your control panel first. Now, in your control panel, go to network and internet. In network and internet, go to network and sharing center. Click on change adapter settings. Now, right click on the adapter for which you want to change the IP. Properties, IPv4, properties, and you assign the IP here. So right now I'm getting it automatically from a DHCP server. But if I had to manually assign it, I have to select the second option here and give those three pieces of information. IP address, 0 dot, let's say 100, and the subnet mask for it, and the default gateway, the router's IP, which is usually your first IP in the network. Okay. Now, along with that, for internet connections, it's going to ask you two more pieces of information called DNS server. Okay. So just in case if you don't know what to enter here, you can go to your browser, and in your browser, you can search for Google DNS server IP. And now when you hit enter, you can notice it provides two addresses, 8.8.8.8 or 8.8.4.4. And you can use any one of them over here. So these are global DNS servers provided by Google itself, okay, that anyone can utilize. But again, I know you might not understand what a DNS server is for now. So I'll explain that in a minute. Okay. But for now, if you don't know what to enter here, you can just defaultly go for 8.8.8.8 or 8.8.4.4. And as soon as I click on OK here, my IP address will change to 0.100. But now I won't be doing that, guys, because we will get disconnected from the meeting. My connection is going to reroute if I change my IP. So I'm not going to do that. Okay. But if I click on OK here, this will be the IP assigned to my Wi-Fi interface. Okay. So now I'm going to go back to the old method, obtain an IP address automatically from a DHCP server. Okay. But what is a DHCP server and how am I getting an IP automatically is the question. Okay. So before we get into that, any doubts or questions up to this point regarding the manual assignment of IP?
Okay, is that subnet mask is the maximum of the IP range? Class A or Class B or Class C IP range, maximum value of the Class A, Class B, Class C IP range.
Wouldn't be that, right, Shiva? Because if you go to the IP ranges for Class A, Class B, or Class C, the ranges are different. For Class A, it starts at the first IP 0000 and goes up to 127, 255, 255, 255. That's the range, right? For Class B, it
Yeah.
starts at 128 and goes up to 191. For Class C, it starts at 192 and goes up to 223. So if you notice over here, none of the subnet mask values are over here. Okay. Subnet mask is just used, as mentioned earlier, to understand which IP belongs to which class. So your classes have a unique number of network and host portions. Class A has one network portion, Class B has two network portions, Class C has three network portions. And we discussed yesterday, what are these network portions and host portions and what is their relevance. So depending on those network and host portions itself, you have the subnet mask. Okay. So wherever there's a network portion, you have 255. Wherever there's a host portion, you have 0. So for Class A, with one network portion and three host portions, subnet mask is 255000. For Class B, it is 2552550. And for Class C, it is 255255250. Okay. So these are not the starting or ending ranges. This is just to understand how many network and how many host portions are there in each of these classes. And from that information, you get to know what is the range. Okay. How many devices
Okay.
can each.
For example, if for Class B, this is the starting value 111 and ending should be 255 and 00. That is the max.
No, no, no. This is the binary number. And when you convert that binary to decimal, you get 255.
Yeah, yeah,
Were you
yeah.
there in the first class,
That
Shiva?
means it's 192,000 something we will get if I convert to the binary. But the
If
maximum
you
is
convert what?
one.
When you convert this all ones, you get 255. When you convert these all ones, you get 255. When you convert all zeros, you get 0. When you convert all zeros, you get 0.
Oh, okay,
This is
okay,
the conversion here. This is not the range. This is conversion. This is the binary
okay,
value, and this is the decimal value.
okay, okay, okay.
Okay. Right. Right. Perfect. Moving forward now, as mentioned. So when we talk about a DHCP server, now what is DHCP and why do we use it? So as mentioned already, DHCP server is to automatically assign IPs in a network. From the name itself, we can figure out what it does. So DHCP stands for Dynamic Host Configuration Protocol. Dynamic, let me write it down. Dynamic Host Configuration Protocol. Okay. So from the name itself, you can figure out it is used to dynamically or automatically configure an IP address, internet protocol address to every host in the network. Okay. And this happens with something called the DORA process. Okay. So whenever you have a DHCP server in your network, that DHCP server has a pool of free IP addresses. And from that pool of free IPs, it assigns each IP to each other system connected in the network. Okay. And that assignment is done with something called the DORA process. So let's talk about this DORA now. Okay. So now let's assume, so I'm going to draw this out. So let's assume we have our DHCP server here. This is my DHCP server. And your DHCP server usually gets the first IP in the network. Let's say 192.168.0.1. So in our home network, our Wi-Fi router itself acts as a DHCP server. Okay. And this DHCP server has a pool of free IPs. So it has a pool here, pool of free IP addresses. Okay. So from the next IP, which is 192.168.0.2, 192.168.0.3, then 0.4, 0.5, like that. It goes on up to 192.168.0.254. Okay. You won't use the 255 IP, guys, because if you remember in the last class I've mentioned, the IP 192.168.0.255, this last IP is called the broadcast IP. Okay. So this has a certain specific purpose. I'll explain what it means in a minute. But this is called the broadcast IP. And this cannot be assigned to any system in the network. Okay. So now whenever there's devices in the network here, let's say if there are other devices here, okay, your DHCP server assigns each of these devices a unique IP from the pool. How does it do that? With the DORA process. So this can get 192.168.0.2, the next available IP. And this can get 192.168.0.3, the next available IP. And whenever those IPs are used here, they're removed from the pool again. So now the pool begins at the next IP, 4, 5. Okay. So once an IP has been utilized, once it has been assigned to a certain system, that IP is removed from the pool because it should not assign that same IP to another device again. Okay. So now let's say we bring one more device in the network. So we have connected one more new device, let's say. Okay. So whenever this device is connected to the network, and if it is selected on this option here, where did that go? CPA.CPA. Yeah. So when it is selected on this option here, obtain an IP automatically, this first option, what this device now does is it uses the broadcast IP to send a packet to every other device in the network. So it sends a packet on this IP, 192.168.0.255. So when a packet is sent to this IP, it goes to every other device in the network. So that's what broadcasting means, one to all. Okay. And this packet is called the discover packet. Okay. So it is trying to figure out who the DHCP server is. It's trying to discover where the DHCP server is located. So it's asking this system, are you the DHCP server? Then it says, no, I'm not. So it rejects the packet. Then it asks this device as well, are you the DHCP server? It says, no, I'm not the DHCP server, and it rejects that also. But when it reaches the correct server here, this server now responds back saying, hi, you have been looking for me, and I am the DHCP server, and now I can offer you an IP address. So now from the pool of IPs, it offers a free IP, the next available IP, 0.4. Okay. Now when that offer is made, your client now says, so this is the client here, guys. So let's call this the client, and this is the server. Okay. So now your client says, hey, thanks for offering me that IP. I request you to allocate that IP to my system and do not assign it to anyone else in between. So now a request is made to, again, reserve that IP. Oh, sorry, escape. To reserve that IP for this device. So a request is made. And for that request, your DHCP server finally sends an acknowledgement, a confirmation, saying, hey, I've got your request, and I acknowledge that request, and I confirm that this IP now has been assigned to you. And with that acknowledgement, this device gets that IP, 192.168.0.4. Okay. And this entire process is called the DORA process. D for discover, O for offer, R for request, and A for acknowledgement. Okay. And all of this happens very spontaneously, guys. So I am pretty sure you might have observed this at least once in your life. So if you connect your phone to a Wi-Fi router, if you're connecting to a new network, when you excuse me, When you enter the password and when you click on connect for a few seconds, you see this message, obtaining IP address. Not sure how many of you have ever observed that. Okay. But when you see that message, obtaining IP address, it's your phone communicating with the Wi-Fi router and performing the DORA process to obtain an IP. Okay. So that's what happens in the background, the DORA process. Okay. D for discover, O for offer, R for request, and A for acknowledgement. Okay. Is that clear? Any questions, any doubts up to this point? Om Prakash, Faisal, Shiva.
That's fine.
Who else is there? Kishore. Kishore Venna. Kishore, is this your first class? I've not seen you in the earlier sessions.
No, yesterday I have seen you. First day I didn't. This is my second class. Yesterday I have seen you
Oh,
for
you were
the
there.
classes. Yeah, I am there.
Acha, acha, okay, cool. Right. Any questions, Kishore?
Yeah, I got it. That HCP submitting.
Good. Right. Moving
And
forward.
how about the notes? This material, are you going to share us to the email,
Yeah,
something like?
definitely. So for now, you only get the recordings on YouTube, Kishore. But once you have registered for the course, these documentations will also be shared with you. You'll be getting these
I
presentation
am
slides.
already registered to the course. No, I am
Oh, you've already
already.
registered. I didn't get that information yet. So if you have already registered, you'll be getting this on your mail itself, Kishore. You'll be getting this documentation on your mail.
Okay, I didn't get that information. kkvenna9@gmail.com.
Can you type that
Yesterday
out in
also,
the chat?
yeah, I will do that.
Sure. I'll send the notes to you, Kishore. Don't worry. Right. Right. Moving forward now. So this is about the DHCP protocol, guys. I hope no questions for anyone up to this point. Okay. Right. Now let's talk about the next server, which is a DNS server. So if you remember when we were assigning a manual IP, we entered two IP addresses, 8.8.8.8 or 8.8.4.4. And they were called the DNS server IPs, Google DNS server IPs. Now, what does a DNS server stand for and why do we need it? So DNS stands for domain resolution. Again, it performs domain name resolution. Okay. So it's called a domain name server. Okay. And it performs resolution of domain names. What I mean by that is basically, let's assume, again, let's call this the phone book of the internet. Okay. Now in your phone, you have a contacts app, right? What does that contacts app do, guys? It links every contact name with a contact number. So if you get my number, you save it with some name. You call it, you save it as Shoaib, or you save it as cybersecurity trainer, you save it as DurgaSoft trainer, whatnot. Okay. Now it is irrelevant for your SIM card what you save the number as. The name, okay, is only for your remembrance, for only for you to recall who this person is. Okay. But when you need to make a call to me, you make it on the phone number itself. So from your 10-digit contact number, a call is initiated to my 10-digit contact number on the SIM card. Okay. You can save it as anything, but the relevant factor here is you need my correct phone number to contact me, right? Similarly, when you go to your browser, and in your browser, when you search for www.google.com, your browser actually doesn't understand this language. It doesn't know what google.com is or it stands for. What your browser actually needs is the IP address of the server on which this website google.com is hosted. So you have a web server somewhere on the internet. And on that web server, this website is running. Google.com is running. So your browser actually needs that IP to connect to Google. It doesn't understand this language google.com. It works on IP address. All the connections on the internet work on IP addresses. Okay. So that's why what happens is this connection now, this request now first goes to a DNS server, where a DNS server maintains a record. So it's like the contact book for websites. Okay. So it maintains a record saying so-and-so website is on so-and-so IP. So google.com is hosted on so-and-so IP. Bing.com hosted on so-and-so IP. YouTube.com hosted on so-and-so IP. Shrow.com hosted on so-and-so IP. So when you make a request for Google, that goes to the ISP first. From the ISP, it reaches a DNS server. And from the DNS server, it gets to know, okay, google.com is hosted on this exact IP. And from there, it reaches that server with that IP. Okay. So your DNS server is like the internet's phone book, translating human readable domain names into IP addresses. Okay. When you type a URL in your browser, the DNS server resolves or converts that domain name to the corresponding IP. and therefore it allows your device to connect to the intended web server. Okay. If I show you an example for this, I can go to my command prompt, and in my command prompt, I can run a command called ping, P-I-N-G, www.google.com. Ping is a command for checking connectivity, guys. It sends something called ICMP packets, Internet Control Messaging Protocol packets. So they are a packet of 64 bytes or 32 bytes. Okay. And again, it is to check if the system is responding or not. So when I type ping www.google.com, my system starts sending some packets over here. As you can see, bytes 32. So it's sending 32 bytes packets to the server, and that server is responding back. It says, hi, I'm replying back to your packet. So 4 replies are received here. So my system sent 4 packets, it received 4 packets, and there was 0 packet loss, which means everything is perfectly fine. Okay. But when I'm getting a reply, if you notice, I'm getting a reply from an IP here, 142.250.182.4. If I copy that IP, if I go to my browser, and in my browser, if I paste that IP here, and if I hit enter, carefully observe what happens. It opens google.com. So this was the actual IP for Google, guys. But you don't have to remember this 12-digit number or whatever it is, because we have a DNS server in between. That DNS server actually links this IP with this domain name. So whether you type the IP or the domain name, you're reaching the correct intended server, all thanks to a DNS server here. Okay. If you didn't have DNS servers, you would have to remember the numbers or the IP address numbers for each website. Okay. But again, our job is made easier with the help of a DNS server, linking every domain name with its exact IP. Is that clear, everyone? Shiva, Kishore, Faisal,
Yes, yes.
Om Prakash. Perfect. Moving forward, let's talk about the last topic for today, which is special IPs. Now, in your entire range of IPv4 addresses, guys, there are 2 special IPs. One is called as loopback, and the other one is called as APIPA. Now, these IPs are neither public IPs nor private IPs, guys. They're not used for communication. They're only and only used for troubleshooting. Okay, so if your system has an issue, you can use these IPs to figure out what the issue is. Okay, so firstly, there's a loopback IP ranging from the number 127.0.0.0 to 127.255.255.255. Okay, and this loopback IP is only used for one single purpose: to figure out if your NIC card is working properly or not. Now, what do I mean by an NIC card? So if you go to your browser, in your browser, if you search for NIC card, it stands for Network Interface Controller Card. And this is what it looks like actually. Okay. So if I open this image specifically, too small. Open image in a new tab. Yeah, much better. So if you notice over here, this is what an NIC card looks like. If you have a laptop or a computer, your system might have an Ethernet port. So you see this as an Ethernet port, okay, where you can connect RJ45 cables for LAN connections. And right beside that Ethernet port, you see this chip here. Okay, so this Ethernet port is mounted on that chip. So this chip is the main chip responsible for all your network communications. Okay, so your NIC card contains all the physical networking components for your adapters on your device. So if I go to my control panel again, you can see these are all the adapters available on my device: my Wi-Fi adapter, the Ethernet adapter, etc., etc. So all these adapters, physical components, are stored on this one singular chip here. Okay, and this chip is responsible for all your network communications. Okay, if this chip malfunctions, your system will neither be able to retrieve an IP, nor will it be able to communicate with any other device. Okay, so that is why you need this chip working 24/7 as long as your system is active. Okay, just give me 1 second. Apologies about that. Now, coming back to this, as mentioned, so if this chip malfunctions, your system will not be able to retrieve an IP. And if it doesn't get an IP, it cannot communicate with other systems. Okay. And to verify if this chip is working properly or not, you have the loopback IP. How do you check that? Same command, ping. Just go back to your terminal, type the command ping, and give any random loopback IP. So the first number can be 127, the first octet, and the other octets can be anything. They can be 0.0.1, or they can be the last IP as well, 255.255.254, or any IP in between as well, 123.35.45, any random IP. And when you hit enter, you should get a reply back like this. If you're not getting a reply back, it means your system is, system's NIC card is not functioning properly. Okay. So 4 packets were sent, 4 packets were received, lost 0 packets, which means your NIC card is communicating back to you. Hence, everything is perfect. Okay. So you must have understood by now why it is called loopback, because you're trying to loop a connection back to your own system. There's a loop, you're communicating to yourself. Hence the name loopback. Okay. Moving forward, after loopback, you have a PIPA. It stands for Automatic Private IP Assigned Addresses. And these range from the number 169 to 5400 to 169 to 54 255 255. And these are a special case IP, which is assigned by the operating system itself. So when your device cannot get an IP from both the methods, manually from a user or automatically from a DHCP server, in such a scenario, your operating system itself, the OS, Windows or Linux or Android or whatever it is, that operating system itself assigns an IP. And that IP is in this range, a PIPA range. Okay. So when you see an APIPA IP, you have to figure out that something is wrong in your network. So your DHCP server is not functioning properly, or you've forgotten to assign an IP manually. So that is what the APIPA IP is used to indicate. Okay. That an actual IP is missing from both manual and automatic methods. Okay. So that is about the special IPs. Now they're not used for communication. None of these IPs can be used for communication, guys. They're only to indicate something wrong in your network. Okay. Is that clear? Any questions, any doubts up to this point? Shiva, Kishore, Faisal, Om Prakash.
Clear, sir.
Right. So yeah, nothing further, guys, for today's class. This is the last networking session. Tomorrow we'll be having the last demo, which is a practical session where we learn how to install this application called VMware. So this is required for a practical hands-on lab setup. I'll show you how to install VMware. And in this, how do you install this operating system called Kali Linux? This is what we're going to learn in the session tomorrow. Okay. And there's one more topic actually in networking called CIDR. But this is an assignment for you. I would want you to do some research and tell me what is CIDR and what is it used for in the next session, if time permits. It stands for classless interdomain routing. So whenever time permits, I want you to do some research on this and let me know in the next session what CIDR is used for. Okay. Yeah. If there's any questions. Right. Frankly speaking, exactly correct. But why do we need a substitute is the question.
Hello.
So when we already have subnet mask, why CIDR again separately? Okay, no worries. You can do some research on that, guys. And if you get an answer, well and good. If not, no worries. I'll explain it myself in the next session. Okay.
Hello.
No worries, Shiva. It's okay.
No. Hello.
Oh,
Can you hear me?
One second. Prakash, I can hear you, but you're on a different link, sir. Oh, Prakash and Prakash are two different people. Yeah, Prakash, is this you, Prakash, or if it's someone else? Sure, you can, if you want to contact me separately, here's my number, Prakash. I'll drop it in the chat box. You can send me a message on WhatsApp. Yeah, I'm dropping it in the chat box right now. It's 984998477 with +91 in the country code. So if you're contacting from US, +91 will be the country code.
Hello.
Right. Others, any questions? Shiva,
Hello.
Kishore?
Can you hear me?
Yeah, Shiva, I can hear you.
Okay. So is the class every day at 9 to 10?
Yeah, 9 to 9:45 actually. The last 15 minutes are for doubt sessions or so, if anyone has any
Okay.
doubts also. Since these
So
are demos and all, we're taking slightly
are you
shorter.
taking every day?
Monday to Friday, every day. Shiva.
Okay, Monday to Friday. Okay. Actually, previously I joined your class in the evening session.
Okay.
Yeah, actually, I'm working in South Africa. Actually, it's time
Oh,
difference is 3.5 hours.
acha,
So
acha.
in the evening classes, actually, that is my office time. So
Oh,
when you are teaching at 8 o'clock, 8 to 9, so it's around 4:30 to 5:30 session in South Africa. So that's
oh,
why I couldn't able to join there. So in the morning
okay,
session, now it's here 5:30, so it's easy for me to join.
okay, okay. 5:30 in the morning, Shiva.
Yeah.
Oh my God, that's too early for you.
So normally here school starts at 7 only.
Oh, that's interesting.
So it's a 7 to 1:30.
Acha, acha, acha. That's interesting. Okay, sure. This again, we are gonna continue this batch, Shiva. So no worries. You can join these sessions every day at 9 a.m. in the morning, but only from Monday to Friday. Again, as mentioned, we have classes only on weekdays, no weekend sessions. And yeah, for a 35 duration course, for a 35 days duration course, 1 hour each.
Okay, okay.
Sure. Yeah, Prakash, you were saying something. As mentioned, 35 days, Prakash. Right. And if you have any further questions, guys, here's my number. I've dropped it in the chat box and the Zoom also. Let me drop it once. If you have any
Sorry,
query,
I didn't join in the first class. Can I have the first class as well so that
who okay, sure, yeah. Okay, so if
myself?
you've registered, if you go to your Google Drive and if you go to the shared with me folder there, from Monday onwards, you're gonna get all the recordings in your Google Drive directly for all the registered students. The institute is gonna share them on your Google Drive directly to you. So you'll be having all of them in the Google Drive shared with me folder. Okay, so on the left panel, you'll see one tab called shared with me. If you click on that,
Okay.
since Monday we'll be having the registered link, so only registered students will be allowed from Monday. So from Monday onwards, you'll be getting the previous links as well, previous classes as well, recordings. If not, for now,
And
if you want it, you
I'll
can
get
also,
the material as well. You showed in the
yes,
PowerPoint presentation.
right,
Okay.
right. You'll be getting the PDF, the converted PDF for the same presentation. So you'll be getting it on your
Okay.
email directly. Yeah.
Okay. Thank you.
So yeah, that's nothing further for the session today. Please do join tomorrow without fail. It's our first
And
practical done. Yeah.
and yeah, I got the credentials in the message saying that it is Google Pay, but I want the phone pay number. Can I have the phone pay number so that I can make
Uh,
the
I think it's same for Google Pay and Phone Pay both, Prakash. I
okay,
mean, for
okay.
sure. I
Sure.
think it should work for both Google and Phone Pay as well. If not, you can just
Okay,
contact the institute once. They have given the contact numbers, right?
okay,
9262 something something. Okay, you can contact on those numbers as well. Okay,
okay.
right. And yeah, as mentioned, please do join the session tomorrow without fail. It's going to be our last demo. And I hope you have registered already, guys. If you have not, please do register at the earliest. From Monday, the link will change. This link will not be active from Monday. Only for the registered students, the link will be provided. Okay. And tomorrow, we're going to have the first lab setup session. Yeah, Prakash. Okay. Sure, sure, sure. No worries, Prakash. Sure. Okay. Bye, guys. Thank you. See you tomorrow at the same time.